for a parabola, and then I asked you to kind of to get warmed up to do the transformations. If you didn't, go ahead and write down what you were doing in each of these steps. The first transformation would be a vertical stretch by 2 because the multiplication is happening on the outside of the function. And then the second set of transformations would be a shift left by 2 and down by 5. I need you to know what happens to the coordinates when we do things like vertical and horizontal stretches. Stretches just cause a multiplication to the coordinates. So to go from the first table to the second table, I kept all my x values exactly the same because the x values don't change when you do something vertically. But all my y values got multiplied by 2 because it was a vertical stretch by 2. In my second transformation, I just added and subtracted from each of my x and y values. So to go from my x values to my new x values, I subtracted 2 because we're moving to the left by 2. To go from my old y values to my new y values, I was subtracting 5. So just taking this opportunity to review transformations, it is one of those things from chapter 1 that we're going to see again and again and again all year long. Transformations, we'll be using them when we graph polynomials in this unit, rational functions, when we graph exponentials and logs in the next unit. We'll use transformations when we graph sines and cosines, and semester 2 we'll be using transformations. So keep these skills sharp. You should be able to look at a function and see what's going on inside, what's going on outside, and know whether that's a reflection or a stretch or a compression or a shift. Other things you're going to be seeing a bunch in this unit from last unit will be domain and range. We'll be getting into those in a couple new contexts. But today our focus is on quadratics. I'm going to say that most of you probably spent 3 weeks or so last year doing quadratics, spending time on vertex form and standard form, finding the vertex. There's some formulas that we use. We're just going to review all that stuff today. If you find as we're reviewing that you already remember this stuff from last year, you're welcome, as usual, to ignore me and work on the homework. We are going to be completing the square, which is a big thing. If that doesn't sound familiar to you, or if you don't have like really good memories of that from last year, make sure you pay attention to that question. Did I draw a point wrong? I didn't take it down far enough, did I? Thank you. This point should be down there. Thank you. All right. So, are you ready? I can't wait. Good. All right. Does this look familiar to you? This vertex form? Remember seeing that last year? Did yours have A's and H's and K's in it last year? Or did it have different? You used H's and K's? Oh, good. So this will be very similar. Our textbook uses the same kind of notation. And then we know that we can find the vertex if we've got something in vertex form by just looking at the value of H and the value of K. And the axis is just going to be using the value of H. So knowing that, we could do the same problem that we just did a moment ago and graph it a little bit quicker by just finding the vertex and drawing a parabola that's opening upwards. So this is the same problem we did a moment ago. We got x plus 2 in there. What is H? H would be -2, and K would be -5, which means our vertex for this parabola should be at -2, -5. And if you check, I think after our correction just a moment ago, we do have a vertex at -2, -5. Thank you for correcting me that. That would have been totally wrong. And we can find our axis by just writing the equation x equals, and it's whatever H was, H was -2, so x equals -2 would be our axis. The axis is a line that cuts through the vertex and splits the parabola in half. All right, so we've seen vertex form, that's great. Vertex form is pretty convenient. Standard form, a little less so. You're gonna want your calculators out. I'm gonna show you some cool stuff you can do on your calculators in the context of what we're gonna do here with standard form. All right, so standard form, not so convenient, but if you have values for A, B, and C for something in standard form, we can also use those to find H and K. So H is given to us by this super fun formula. H equals the opposite of B over 2A. And K is given by F of H. Basically, you take the H value that you got from this, plug it back into the original function for X, and that's going to give you your K value. That's the part that's kind of a pain. I'm going to show you how to do that on the calculator. So, all right, so let's look at this example. I totally screwed this up when we did this on Friday in my other section, because I made it tricky on purpose, and then I forgot that I made it tricky. Do you see how I made this tricky, this example here? What did I do? Yeah, it's not in standard form, is it? And I looked at that and I got fooled. I wrote A equals 7 and B equals -2 and C equals -3. So there's an opportunity for you to learn from my mistake. I'm going to rewrite this in standard form and hope that I have some more success with this the first time around today. All right, so now that I got it in the right form, A is -2, B is 7, and C is -3. Just like with the quadratic formula, we never include x's in our A, B, and C. So then H is just going to equal the opposite of B over 2A. And B was 7, and A was -2, so I'm just filling in those values. And we'll simplify that. I'm going to call that 7 over 2%. So we got H. Any questions about finding H? So now we got to find K, and K is F of H, or F of 7/4. So that's what H is, right? So that literally means take 7/4 and pop it into your equation. I'm going to let the calculator do the work for us on this. Yeah, I mean, it's not, we can do it. It's just, we'll let the calculator do the hard work. So I'm going to show you something new here. Maybe it'll be new. Do y'all know about the stow button in your calculator? I'll take that as a no. Do you know about the stow button? So check this out. Go ahead and type in 7 divided by 4. I'm not going to hit enter. I'm just going to type in 7 divided by 4. And then down towards the bottom of your calculator, right above the on button, there's a stow button. Hit that button, and you'll see a little arrow. And after this, you can put any letter. basically the name of any variable. I'm going to use X. I like to use X because it's got its own special button. I don't have to do alpha. But if you wanted to do A, you could use alpha A instead. So 7/4 stow X. So what that has done is it has stored the value of 7/4, which happens to be the same as 1.75. That is now in X. So if I type in just X and hit enter, it's going to tell me 1.75 because I've stored 1.75 into X. What do you suppose I'm going to get if I type in X plus 2? 3.75? Yeah, it's going to take the 1.75 that's already stowed in X and add 2 into it and give you 3.75. All right, this is super useful when I've got to do something like this because now I don't have to type that 7/4 in a bunch of times. I've got the 7/4 already stowed in for X. So now I can just type in this equation or this expression, negative 2x squared plus 7x minus 3, and hit enter, and it'll do all the work for me. Hey! They give me 3.125. Now there's a way I can ask my calculator to turn that into a fraction. Do you know how to ask for a fraction version of an answer? It's under the math button, which is right underneath your alpha button on the left-hand side. And it's the first option that you'll see when you hit the math button. So I usually just do math and then enter. That brings the frac back. So now I'm asking for my calculator to turn that previous answer into a fraction. When I hit enter, it'll say 25/8. Okay, so basically we just did this in our calculator and got 25/8. So after all that work, now we finally have our vertex at 7/4, 25/8. First pole never. And we have our axis at x equals 7/4. The instructions in that little table down there are kind of a more complicated version of what I just showed you. We're not going to go over that right now. Okay, so far, mainly review. Have you seen this stuff before? Yeah, okay. Do you guys remember completing the square? Remember doing this last year? Kind of. There's ways to use the diamond. There's different ways to look at completing a square, and there's different kind of techniques to use. Oh, what a good question. How do you unstow something? So my answer to that is going to come with a question. Number one, what's your purpose in unstowing it? If you want to put something different in there, just stow something over top of it. So right now my x is 1.75, but if I wanted to, I could make my x 3.65. Stow it into x. Now x isn't 1.75 anymore. So no, it will not mess it up when you try and graph things. However, if I go into my graph now and say I graph something, that will mess up my value for x. Now my value for x. So when you use the graph, it's going to overwrite anything you have stowed for x. So that's the only reason that I would ever recommend using A or B or C or something other than x is if you're going to have to graph something, whatever you put in for x is going to get overwritten by the graph function. But no, it won't mess anything up having something stored in there. Good question. And the only way to unstore something is to write over top of it. There is, and then there's a memory menu here that you can use to reset everything with memory management. Delete that'll take it back to the factory settings. Once you get some programs in there, though, you're not going to want to do that. We'll look at some programming later on this year. Okay, let's talk about completing the square. Completing the square comes up in this class in a couple different places, and it comes up quite a bit in calc. So it's a skill that we want to be good at. I'm going to introduce it kind of in a two-step process. So we're going to talk about perfect square trinomials first, and then we'll use it as a jumping off point for completing the square. So this next part's super important. I want you to actually understand what you're doing when you're completing the square, and that's where this next part's going to be important. So follow along with me if you would. Is this a perfect square trinomial? I'm going to show you the way to check and see if it's a perfect square trinomial. The key is to look at the b coefficient, which happens to be +6, to cut it in half, so divide it by 2, which would give you +3, and then take that value and square it. And if you end up getting the c coefficient, then it is a perfect square trinomial. So you take the middle coefficient, you cut it in half and square it. If you get the constant term, then it's a perfect square trinomial. Is this a perfect square trinomial? Yes. Check the second one with me. Take the -10, cut it in half. You're going to end up getting -5 and square it. Are you going to get 25? So yes, this is a perfect square trinomial. Can you check those last two and just verify for me whether these last two are also perfect square trinomials? I'm hoping you were able to verify that all 4 of these are perfect square trinomials. Are we good? All right, so don't miss this. This is kind of the key piece. If something is a perfect square trinomial, then that means it's really easy to factor. I don't need to do an X box for this. There's a shortcut. If it's a perfect square trinomial, it's always going to factor into x plus or minus something squared. So all of these are going to factor into the same format. And this number we got when we were testing it is the number that we use. So this one would be x plus 3 quantity squared. This one would be x minus 8 quantity squared. So can you fill out the final factored version for me for those two on the right? All right. So do you feel like you could recognize a perfect square trinomial? And once you found that it is a perfect square trinomial, can you factor it quickly using the shortcut? We feeling good about this? All right, so we're going to move on to completing the square. And what this does, this is an algebra trick that we can use to take something that looks like this and turn it into something that looks like this. This is useful if I have something in standard form and I want to get it into vertex form in this context. But there are many other contexts where you use this to force something into another format. So I don't want you to think this is the only place we'll use it this year. It's pretty easy to do, but the part that's hard is keeping things balanced. So do you remember last week we found ourselves, well, 2 weeks ago, we found ourselves multiplying by fancy versions of 1. Do you remember that? We were multiplying by like x minus 1 over x minus 1. That's just 1, right? It's a fancy version of 1. Okay. So that was multiplying by a fancy version of 1. What we're going to be doing a lot with completing the squares is adding a fancy version of 0, because adding 0 doesn't change something, right? Here would be an example of how I could add 0. I might add 16 and then subtract 16. Would you agree that overall I haven't changed anything if I do both of those? Or I might add 3 times 8, and I might subtract 3 times 8. Same thing, doing the same thing. It's a fancy version of 0. All right, so here we go. Let's do an actual problem. Let's see if I can remember how I set this up originally. No, let's go up to here. All right. So the idea here is I'm going to start off with an equation. The equation looks like this. The second step I wouldn't really write out, but the whole idea here is, would you agree that I have not changed this equation right now? It still has an x squared, it still has a minus 6, and it still has a plus 12, right? And what I'm going to say is that whatever number I put in this blank, I'm going to put the same number in this blank. So would you agree that overall this is going to stay balanced? I'm going to add some fancy version of 0. I just haven't filled out what version of 0 I'm going to do yet. But I'm adding something and then I'm taking the same thing away. So it should be the same as the original equation. All right, here's how we figure out what we're going to put in there for a fancy version of 0. We take our middle term, and basically I'm going to force this to be a perfect square trinomial. So I got to figure out what would I put in here that would make this a perfect square trinomial. Well, to check, remember we took the middle term, we cut it in half. So -6 became -3. And then we squared it. And that gave us 9. Now that is a perfect square trinomial. We forced it to become a perfect square trinomial. Where else do I need to put that 9? We agreed that in order to keep this balanced, that we would put the same thing in both spots, right? So this 9's got to go in here as well. So just doubling back to our original equation, would you agree that we have not changed anything? We still have an x squared, we still have a -6x, we still have a plus 12. I've got a plus 9 and a minus 9 in here, but those would ultimately cancel each other out and leave us with the same thing, correct? So we haven't changed anything, we've just changed the way that it looked. Well, this is great because now this parenthesis factors using that shortcut, and it's really easy to factor. That just becomes x minus 3 squared. That 9's still sitting over there. And all we have now to do now is clean it up. That's x minus 3 quantity squared plus 12 minus 9 is 3. And there we go. You guys, does this look familiar to you? Do you remember doing this last year? Now it's kind of coming back. Was it kind of the same idea, like cut the thing in half and square it? Was that sort of your method before? There's some other ways to look at this, but that works pretty well. Let's do another one. Now things get a little bit trickier with this when there are coefficients in front of the x squared, because this doesn't work if there's a coefficient in front of that x squared. The whole perfect square trinomial trick that I showed you doesn't work. So that's okay though, because we can deal with this. What I'm going to say is for my first step here, I'm actually going to factor that 3 out. And I'm really just focusing on my first 2 terms. In fact, I'm going to go ahead and leave my plus 7 out here. And if I factor that 3 out, this would become an x squared minus 4x. I'm going to leave a little blank here. I guess I know it's going to be a plus. Now, ignoring that blank, double check that. Would you agree that that is the same as the expression we started with? Is it still a 3x squared? Will we still end up with a minus 12x? Do we still have a plus 7? Are we all in agreement that that's the same? All right, but if I throw something in here, then whatever I throw in here is going to get multiplied by 3, and that's going to unbalance stuff. So how am I going to rebalance it? Well, I'm going to put the same thing over in this spot. And since this one was multiplied by positive 3, I'm going to multiply this, copy it over here by negative. This is where it gets kind of weird for people. I want you to think about this 3 that's eventually going to multiply by that blank, and this negative 3 that's eventually going to multiply that blank. And can you convince yourself in your head that eventually that stuff's going to end up canceling out? Are we okay with why we had to have this negative 3 in front of our blank this time? Right, so looking back at it, notice I got a 3x squared still. I'm looking at my original equation, that matches. 3 times negative 4 is negative 12. The 7 still appears, and it's not getting multiplied by 3, so that's good. Anything that I put in here and here is extra, though, so I need to make sure they cancel out. So I'm going to put the same number in each spot. Now, this first spot's going to get multiplied by 3. So to make sure it cancels, I need to make sure my second one gets multiplied by negative 3. Are we good? All right, so let's figure out what goes in there. We do our whole cut in half and square it. Now that we factored everything out, we should be in good shape. Divide by 2 gets us negative 2. Square that gets us a 4. We're going to fill that in both spots. And what do we got here? What should be in my parentheses? X plus or minus what? X minus 2, because that's what we had there. Final answer, 3 quantity x minus 2 squared minus 5. All right, we're going to do one more of these. Any questions before we move on? One more for good measure. All right. So just like the last one, we're going to have to deal with this coefficient. If the coefficient is not 1, then you're going to have to factor it out. So just like we did in the last one, let's factor just out of the first 2 terms. Go ahead and leave the minus 4 sitting outside of our parentheses there. Just focus on these first 2 terms here. This would become an x squared minus 3x, if I'm not mistaken. Double check that and make sure that matches. If you were to distribute that negative, would it match what we started with? I believe it would. And then we're going to think about sticking something else in there to make that a perfect square trinomial so it'll factor. So I need that same thing out here. How am I going to keep things balanced this time around? If I put the same number in here as I put in here, what do I need? What sign do I want in front of this parentheses?
Plus.
A plus, because it's got a minus already being multiplied over here. So we want a plus over here. That should work, right? We are going to balance there. So cool. Any questions about where that plus came from? Negative times that, positive times that should cancel, should balance. All right. I think we're going to be dealing with some fractions here, but that's okay. We're not afraid of fractions. Negative 3 divided by 2 is negative 3 over 2. Negative 3 over 2 squared is, well, it'd be positive 9 over 4, right? Square the top, square the bottom. So we'll add 9 over 4 in that spot as well. Just for my peace of mind, are we sure? Yes, that's a minus 9 over 4. That's a plus 9 over 4. This should cancel. Everything else looks good. Okay. Now we can factor this thing. We're going to have a minus 3 over 2 inside of here. A negative 4 plus 9 over 4. I'm going to do that off to the side here. Negative 4 plus 9 over 4. That's negative 16 over 4 plus 9 over 4. That's negative 7. And if you're not super comfortable working out the fraction stuff on paper in your head, don't forget you got a calculator that'll handle it for you. Negative 4 plus 9 over 4. Right, and then just math frac. It's negative 7. Cool. All right. So we're going to use this. We're just going to do 2 more examples. We're going to skip the next example and go on to this one. Oh, you guys are going to love this one though. I don't know. How did you all feel about the quadratic formula? We'll be using that a bunch this year too. Oh, I heard some. Were those excited sighs? No, I don't think so. That exists. Remind yourself what the quadratic formula is. You should be able to write this out for memory at this point. And if not, get on that. Anybody want to sing the song for us? All over 2A. All right, we don't really have room to do 2 examples on here anyway, so we're going to do the second one because it's hard. We want the hard ones in our notes, right? So you're going to see in your homework, you're going to see describe the function, and I have laid out here very specifically what it means when it says describe. So in your notes, it says describe, I need you to find vertex, axis, y-intercept, and x-intercepts. We're going to be using the quadratic formula to find which of those things. Close. To find the x-intercepts. But let's start with vertex and axis. So here we go. G of x equals, now it does say using completing the square, so we do need to do completing the square. We're not going to go with that opposite b over 2a thing. So let's practice here. Completing the square, I see a coefficient that I'm going to want to factor out. That coefficient is negative 3. I'll go ahead and leave my plus 2 out here. What I have left, x squared plus x plus something. And think about how to keep that balanced. If these 2 blanks are going to match, then what do I need to put in front of this parentheses to keep things balanced? Plus 3. This one's getting multiplied by a -3, so we want this one to be multiplied by a +3. I agree. Let's figure out what's going to go in there. This is, well, that's 1. Divided by 2 is a half. Squared is a 4. + 3/4 would be 8/4 + 3/4 would be 11 over 4. Is that what you said? Nice. Oh, I forgot my square there. X is not a point, it's an equation. Cool. Once we get to that point, then it's just a matter of writing down our vertex and axis. Hey, we're halfway done. Question. Why is this a -1/2 and not a +1/2? Great question. So recall that we are looking at things in vertex form. This is all the way from the front page, which is what we did all that work to do to get it into this form. Recall that it is x minus h in the format, and then the vertex is h comma k. Okay, so we have to make it say x minus h. So when I see this, I think of this as x minus -1/2. X plus 1/2 would be the same as x minus -1/2, right? Which means h would have to be negative. It is for the same reason. I want you to think about our transformations. Without this plus 1/2, the vertex would be at the origin, right? That's where our general parabola or vertex is. Plus 1/2 would move it which direction? To the left, which would make it a negative x value, right? Does that kind of make sense? Yeah, good. All right, awesome. What else do we need to find? X-intercepts and y-intercepts. Let's do the easy one first. What's easier to find, x-intercepts or y-intercepts? Y-intercepts are way easier. Because how do you find the y-intercept for any function ever without any exceptions? Plug in 0 for x. It's f of 0, or in this case, g of 0. And normally I wouldn't bother writing this out because normally we aren't taking notes, but go ahead and do it for the sake of good notes. Well, we plug 0 in for x. You probably don't need to write this step out because you can just imagine these terms falling away and turning into 0 because x is now 0. But you're going to get 2. Which means that our y-intercept is a point. Don't tell me your y-intercept's 2. Tell me your y-intercept is 0, 2. Finding the x-intercepts is, in theory, pretty easy. You're also plugging in 0 this time for y, though, right? But then you have an equation you got to solve that isn't so fun. I'm running out of space over here, so I'm going to go kind of up here. We're not doing this example, scratching you out. So if I took this and plugged in for my x-intercepts, I would plug 0 in for y. 0 equals negative 3x squared minus 3x plus 2. Now, if you asked an Algebra 1 student at the end of the year how to solve an equation like that, they'd say, well, there's two options. And the easier one is factor, right? But you might look at that and say, I don't know if that's going to factor. I don't know. I might try it. I might spend a couple minutes trying to factor it. I'll tell you that this one in particular does not. So then we're stuck with the quadratic formula. I'm not going to spend a bunch of time reminding you how to do the quadratic formula, but I will go ahead and write down A is 3, and A is negative 3, B equals negative 3, C equals 2. Can you go ahead and quadratic formulize that? See what you get for your final answer for your x-intercepts, please. I'm gonna go a little messy there. Let me rewrite this. Dividing by a negative 6 would change. So the question is, isn't it a negative 6 on the bottom? I dropped the negative on it because it's a plus and a minus for it. So I factored it out. I guess it would be slightly more correct if I change this instead of plus minus to minus plus. So I factored the negative out of the bottom, which changed the plus into a minus and the minus into a plus. But would you agree that we're just going to have the same thing either way, though, since we had both versions to begin with? When we simplify fractions, at this level of math, when we simplify fractions, we don't want to leave a negative. If we have a negative value in the numerator denominator, we want to get rid of that. So final answer, negative 1/2 plus radical 33 over 6, comma 0, and negative 1/2 minus radical 33 over 6, comma 0. On the test, I'll ask you to write out both copies of it. Don't forget that it's not just that value, it's the comma 0 part is important as well. Any questions about that? Yeah. Yeah, I'm thinking we're gonna have time, right? Because we don't get out till 20. Yeah, we got one more example to do, and then I'll give you guys time to work on it. All right, we got one more problem to do. This one's the easiest from these last couple of pages. Save the last, the easiest for last. All right, here we go. You guys just did a homework assignment where you were writing equations in the form y equals mx plus b, right? Remember doing this? Y equals mx plus b, right? And then remember, you used some points to figure out that, say, the slope was 3/2, but you didn't know what b was. What was our strategy for figuring out what b was when you did it on the homework? We picked a point, right? One of the 2 points that they gave us, a point that we knew it was on the graph. We put the x in for x, and we put the y in for y, and then we were able to solve for b. Okay, we're going to use that same strategy here. This is going to come up again when we're dealing with polynomials. Later this chapter, it'll come up again when we deal with rational functions at the end of this chapter. So this idea of, I'm going to write as much of the equation as I can, but if I still got a variable that I don't have filled in, don't forget, you can always plug an x and a y value from a point in to solve for that last variable. So we're going to write an equation for a parabola. And since they gave us a vertex, I'm already starting out thinking about vertex form, which is y equals a times x minus h quantity squared plus k. And since they gave us the vertex, I know what h and k are. So I can get those into the equation. H is -1, so this is going to end up being an x plus 1, right? I'm good with that one. That kind of goes back to your question from before. So h was -1. Are we good with this being a plus 1 here? Okay, awesome. And then k is -3, so we'll have a -3 at the end. That's great. That's almost a complete equation. The only thing that we're missing here is a. How are we going to find a? Well, they didn't give it to us. They're not going to make it easy on us. But what they did give us was an x and a y coordinate from another point that we could substitute in for x and y here, and then we'd be able to solve for a. So that's our strategy. We'll plug in 5 for y, because that was my y coordinate. Plug in 1 for x, because that was my x coordinate. And we get that nice, simple little equation. We should be able to solve that pretty quickly and figure out what a is. By the way, there's a super common mistake that happens at this step. What do you suppose that common mistake is? X, or the point is 1, 5. Do you think it'd be really easy to put the 1 in for the y and the 5 in for the x? Because the 1 comes first, and so yeah, I do that too. I have gotten burned by that enough times that I always double check and make sure. Okay, now x is supposed to be 1, x is 1, y is supposed to be y is 5. Double check. All right, and then solve. This becomes pretty easy. 1 plus 1 is 2. 2 squared is 4. Couple steps of algebra. Plus 3 on both sides. I don't know why I'm showing my math like this is algebra 1 class. We can skip that. I think a is 2. And now we know everything we need to write our final equation. Y equals 2 times x plus 1 quantity squared minus 3. All right, any questions? Thanks everyone for your attention.